Hello everybody. So today we're gonna continue the problems that we've been doing. I've left this up on the board for a reason. So we just solved for U in terms of T, V, and N, okay? However, this problem now that we're tackling is asking us to solve for chemical potential mu in terms of T, V, and N, okay? And I'm actually just gonna solve this for a one component system. I'm seeing that. So I'm gonna just leave this sort of as an identity that we're dealing with. I'll just write this here. So U as a function of T, V, and N equals 5 over 2 nRT, okay? Now they're asking us to solve for mu as a function of T, V, and N, okay? And so really, what we're gonna do is, again, just what's the first thing we do when we tackle problems? Let's solve for let's write out our fundamental. I'm just gonna go ahead and solve for, okay, you know what, let me not skip steps. TdS minus PdV. Then they asked us to solve for mu, so I'm just gonna solve this as a one component system plus mu dn, right? So ds, when solving for that, I'm solving for ds because I want to have something that I can differentiate, like with respect to something. Maybe I can differentiate s with respect to something to get what I'm looking for. In this case, I'm looking for mu. So I can already see something going on here. So ds is equal to 1 over t du minus p over t dv plus, actually, minus mu over t dn, right? I can already see something, right? Now, when they say in terms of t, v, and n, they want only t, v, and n to be the variables that we're dealing with in our final answer, right? And I'm solving for mu here, right? So I need this u to be gone. Not gone, but I need that u in terms of t, v, and n, right? I need this v, I need this n, and then c, b, a, and r are constants, right? So I'm gonna go ahead and say that del s, del n at constant u and v. Now I'm already seeing a problem here, right? This u, okay, here, that is equal to negative mu over t, right? Once I differentiate this with respect to this at constant this, that gives me negative mu over t, right? I'm gonna go ahead and write that over here just so I can save space for myself. So del s, del n rather. Del s, del n at constant u and v is equal to negative mu over t, right? Okay. Now, I'm gonna erase this and I'm gonna solve for this. So I can say that del n at constant u v of this whole thing, right? So we've done this before. I'm just gonna distribute everything out, right? nr ln of u minus nr, oops, I want that 5 over 2 in the front. Okay. So this whole thing, right? So I'm differentiating this with respect to n at constant u and v, okay? Now, what I'm gonna look for is, hey, is there anything that doesn't have an n inside that I can just cancel out, because I can take it as a constant if it doesn't have an n inside. I can already see this has an n, this has an n, This has an n, this has no n, so the derivative of that goes to 0, okay? So I can say negative mu over t is equal to this, the differential of this whole thing right here is equal to negative mu over t, right? I'm trying to solve for this mu in terms of t, v, and n, so let's go ahead and take a crack at it. I'm gonna pull out this constant, 5 over 2 nr, those are constants here, right? No, I'm sorry, it's not. 5 over 2r is a constant here. U and v are constants, so so I'm differentiating n. So really this whole thing is just n times this whole thing, which is just a constant, right? So this is the differential of this, right? 5 over 2 ln of u, right? Now when I'm moving on, pull out those constants again. This is the only thing here. Well, no, this inside has an n also, right? So I'm gonna pull out everything that I know there's a constant, and then we sort of have to do product rule for this, okay? Because I can already see an n. This is 5 over 2 times r. That whole thing times n ln of an plus bv. So I have to do product rule. Product rule says u dv. Let me write that down. Product rule says I don't know what I'm doing this v. So like v, okay, I'm gonna just do a dab since we're not, I don't know. Dxy, okay? It says x dy plus y dx, okay? Basically just the first term times the derivative of the second times the second term times the derivative of the first. That's product rule. So so that's gonna be n, the first term, which is my n, right? I can rewrite this whole thing as 5 over 2r times n, and then I can, let me just put that in brackets. So we're only dealing with this. This is our constant, okay? So n, which is my first term, times the derivative of the second, which is 1 over an plus bv. But I have to multiply this whole term times the derivative of whatever is in here. So this is a constant, that goes to 0, but the derivative of this is a. So it's a times this whole thing, so it's actually a over an plus bv, okay? Now, that is covered, right? Minus, or plus. So that's 5 over 2. This r is for both terms, right? So I have to distribute this to both terms. So let me go ahead and say, I'm trying to think if I wanna, let me just do this. 5 over 2r. I'm just hoping maybe something will cancel out. I can see this 5 over 2. So let's see. Then I'm gonna do the second term, right? So that's ln of an plus bv times the derivative of the first. And remember, everything is with respect to n. The derivative of this is just 1. So it's just times 1. So I'm not gonna write that in there. Okay, so this whole thing is the derivative of this, okay? And this is actually minus this, so this has to be a minus here because it's minus this whole derivative, right? So this ended up being this plus this, but since it's minus the whole thing, I have to distribute that minus sign to this plus, so it became a minus, okay? So now, again, I'm gonna pull out my constants. 5 over 2, the derivative of this is going to be 1 over cn times the derivative of what's inside here, right? And the derivative of what's inside here with respect to n would just be c, right? So it's going to be 5 over 2 times c over cn, right? And those c's cancel out, okay? But let me just wait and see something. Now, there's already a problem here. I need this u to get out, right? Now, how can I get rid of that u? This is why I sort of kept this here. U in terms of t, v, and n, right, is simply 5 over 2 nRT. So I'm able to say that u, right, because we're solving for mu in terms of t, v, and n, right, I need everything here to be in terms of T, V, and N, right? Now, this U, I need it in terms of T, V, and N, but we've already solved for that in the last video. So I can say this, negative mu over T is equal to 5 over 2 ln of 5 over 2 nRT minus 5 over 2 Rn an plus b v minus 5 over 2 I'm just gonna write this as 5 over 2 times 1 over n, because we canceled out those c's, okay? Now, what else can I do? What else can I do? What else can I do? I'm trying to see if there's anything I can cancel out or anything that looks sort of funny. I don't think so. So I'm gonna go ahead and solve for my mu. If I'm to solve for mu, right, I would first multiply by t, and then multiply everything by -1. That whole thing multiplied by t, right? So, that's gonna be -5 over 2 t ln 5 over 2 nRT minus 5 over plus, because of the negative sign, right? Minus 5 over 2. I'm gonna write this as nRT. nRT times an plus bv minus 5 over 2 r ln okay, so that should be that. Now if I want to clean this up a little bit, do I really need to? And I'm just trying to see if I have any mistakes anywhere. This is supposed to have an something is wrong somewhere. I can see that I think I left out an R here. So because I pulled out, so this is supposed to be 5 over 2 R ln, right? I'm just trying to see if I did anything wrong anywhere. Let me check my final answer. Yeah, this looks correct. Okay, so this looks correct. So I can see some mistakes I made. I didn't multiply by -1s there, but this is basically what you should end up getting for this. Okay, this should be. Let me just double check and make sure that all my numbers are correct and everything. Mu equals Okay, I actually didn't write a negative here for the answer that I said I should get, but I think that was just sort of an arithmetic error. So I think this is actually the correct answer. I think this is actually the correct answer. If not, please just let me know if I made up an error in anywhere inside the comments and everything, and I'll take care of that. But this is what you should get for your mu, okay? You really just have to sort of try and get your S, differentiate your S with respect to something to maybe get just something that you can differentiate and get in respect to T, in terms of TV and N rather. So I think this is what you should end up getting. Yes. Okay. Sorry about my confusion. I'm just trying to make sure I have it right for y'all and everything. But yeah, if anything was unclear, please don't hesitate to ask questions in the comment section, and I'll do my best to answer them. And let's keep learning Thermo. Okay. Thank you.